Thank you, everybody. Welcome to my presentation. My name is Yangjun. I'm now a professor at the University of Winnipeg, Canada. The talk I'm going to present is about string matching with key differences in DNA databases. Here's the outline of my talk. Due to time limitation, the related work will not be presented here. In the following, I first show you what is string matching with key differences, then the main algorithm will be discussed in some detail. It is an algorithm based on two techniques. One is dynamic programming, the other one is BWT transformation applied to a non-target string to generate array referred to as BWT-array. Then we'll discuss the concept of search trees, which will be produced during the execution of our main method. Then the other three techniques, which will be used to improve the performance of our main algorithm. Then our report is fragments and empirically compare our method with some noteworthy strategies. Finally, the talk concludes with a brief discussion on the future work. By the string matching with key differences, we'll find all the occurrences of a pattern in a target string with some differences. In general, we distinguish among three kinds of differences. The first difference is a character of the pattern corresponding to a different character of the target. In this case, we say there is a mismatch between the two characters. The second difference is a character of the target corresponding to no character in the pattern. Then we have the third difference. It is a character of the pattern corresponding to no character in the target. By this example, I just show you a matching of a pattern with a target with the three differences. We have designed an algorithm to solve the problem with two techniques being used. One is dynamic programming paradigm, which is mainly used to calculate the distance between pattern and the targets. The second technique is the so-called BWT transformation, by which a long target string will be folded in some way. Then the search of the target tree can be done very fast. I first discuss the dynamic programming paradigm, which is mainly used to calculate the distance between the prefix from the pattern xi and the prefix from the target by j. By using this formula, here I just use dij to represent the distance between xi and yj. It is a recursive equation to calculate the dij. We'll first calculate all these three values. After these three values have been calculated, we simply take the minimum value among these three values, used as the value for dij. For example, to calculate the distance between pattern x and the target y, we generate a matrix as shown here. The second technique is the BWT transformation, by which we will transform the target string to a BWT array by using surface array of the target in terms of this formula. That is, we'll first generate surface array of target string name by using the relationship between the target, the surface array, and the BWT array to generate the BWT array for the target. As example, for this target string, we'll generate is a BWT array as shown here, then together with the so-called the auxiliary array referred to as F array. The string matching can be done very fast. In this process, we generate such a sequence as shown here. Then the main idea of our method is to replace the target string in the original program with such a sequence. But in the process, we'll recognize all the occurrences of the pattern in the target. Will not go on such a long, only along single search sequence, but we'll search along a search tree defined here. For example, when we just search the BWT array of this target against this pattern, will generate a search tree like this. In this search tree, each path corresponds to a search sequence we have just seen. What is important is, in this process, we'll generate a lot of dynamic programming matrices, each corresponding to a path, corresponding to a search sequence. This method, for example, for the first path, will generate a matrix which contains the first columns as shown here. This method can be improved in 3 ways. The first method to improve the performance is to generate a surface tree for the pattern. Then we just replace the search part of a search tree with a surface tree. Then the second improvement is to recognize similar paths. Then we just use this kind of similarity. We can save some time. Then we just we have the third method to improve the main method by using pattern partition. Here I would like to say something about experiments. In our experiments, we have tested altogether 7 different strategies. The first 3 are all online methods, while the remaining 4 methods are just index-based. We have done a lot of tests in our experiments. Due to time limitation, such test details cannot be reported here. In summary, in this talk, I have shown you a method to do string matching with key differences based on 2 techniques. One is dynamic programming paradigm, another one is BWT transformation. We have shown you the concept of search trees, which will be produced by executing our main method. By using the search trees, we can recognize all the occurrences of a pattern in a target. We have also done a lot of tests, which test the results show that our method is not only theoretically but also practically efficient method. As a future work, we will do string matching with don't care symbols, but using BWT transformation as indexes. That is all for this talk. Thank you for your attention.